everyone! I'm so excited to welcome you back to the next segment for today's Regeneron Science Talent Search public exhibition of projects. I'm Christine Yee, your winner from last year, and we're about to talk to finalists who are studying the change we want to see in the world. Angie, kick us off. When we think about ways science can improve society, life-saving technologies like yours can really make a difference in preventing tragedies. Can you tell us a little bit about your project?
Yeah, so I created a color-changing sensor that you can use to test your drink as to whether or not it's contaminated with a drug or not. So specifically, I looked at diphenylhydramine, which we commonly know as Benadryl, and this can create a lot of effects such as drowsiness and blackouts and amnesia. And essentially, in short, the dye functions using two fluorescence dyes. Fluorescence is what we see. It's that bright color that we typically see in highlighters. And in short, what happens is the drug interacts with one of the dyes, the green dye, which makes it a lot quieter, leaving only the red to continue to fluoresce if your drink has been contaminated. But if not, the green dye is able to fluoresce and overpower the red dye, making the sensor visually appear as green.
That's amazing. Okay, and next up, Emily. You studied media bias. What did you find out, and what should we do to change it?
Hi, so essentially what my project shows is that media talks, specifically newspapers, talks about different individuals differently. The largest result that I found was that black men of all ages are statistically significantly less likely to receive humanizing coverage about if they are murdered than white men of all age groups. However, my most significant result was in the age group of under 18. Young black men are 30 percentage points less likely to receive humanizing coverage than their white male counterparts. Additionally, for women ages 18 to 30 are 23 percentage points less likely to receive humanizing coverage than also their female counterparts. What I think we should do about this is constantly be aware about the communities that we are leaving behind in our content and in our media, because even though we may not be overtly discriminating or speaking negatively towards certain groups, the fact that we're not speaking about or not elaborating on certain instances shapes the communities that we care about.
Awesome. Next, over to Kamisi. Tell us about your findings on sickle cell disease and what you think the next steps are in improving treatment.
I found that modifying antioxidants to have a certain chemical functional group called aldehydes significantly improves the anti-sickling ability and inhibits sickle cell. As for the future of sickle cell disease, I think we need to improve the accessibility and effectiveness of their treatments. Most of the drugs on the market for sickle cell disease only address the symptoms of the disease rather than the root causes, so we need to create treatments that actually prevent the blood cells from sickling instead of just treating side effects of the disease. Also, most patients outside of the US and the UK don't have access to as many drugs or medicines for the disease, and high costs and other things also contribute to them not having access to the treatment that they desperately need in order to live with this disease. So those two things need to be fixed before we can advance in the field.
Awesome, thank you so much. Next, Joshua. What is overfitting in machine learning, and what did you develop to reduce it?
Okay, so overfitting is essentially when a model becomes too familiar with the data that it's being trained on. And when that happens, the goal of an AI model is to be able to train or find patterns in real life. And if it starts to overfit, then it may not have good generalized performance in the real world. And what I developed to fix it is what's called neuron-specific dropout. And neuron-specific dropout is a new regularization technique that compares two sets of data to find out where in a model it starts to overfit. And once it identifies those areas inside of a layer that cause it to overfit, we can drop those neurons by multiplying it by 0, reducing the effects of those neurons in a model.
Amazing, thank you. And now, Hannah, tell us about your computer model. What does it do, and how does it differ from current models?
Yeah, so my model is able to use a combination of both machine learning and math modeling to be able to predict a patient's health trajectory and mortality rate in the future. And so I use longitudinal data, which is data that's taken from the same patient over an extended period of time. And that allows me to intake the entire health history of the patient and use that when the model is predicting its trajectories. And my model is mainly different from other models because it's very accessible to the general population. So anyone, anywhere in the world is able to use my model because the health variables that are taken into account during the prediction are very easily accessible at a traditional doctor's office. And another part of my model that is very innovative is the three-dimensional interaction network. So most current models only go up to 1 or 2 dimensions when analyzing the connections between different health variables during the aging process. However, my model was able to find up to 3-dimensional connections between 3 different variables, and that allows for my model to better reflect the complexity of the aging process. Thank you.
Awesome. And then last but certainly not least, Sadhu. You developed a machine learning tool that can assess suicide risk. What potential do you see in machine learning in solving societal problems?
Yeah, so I think we can all agree that there's so much uncertainty in our world, and I think data can bring us some of that certainty back. And what better way to look at data than machine learning, right? Machine learning makes what was once impossible, parsing through hundreds of thousands of rows of data and finding connections and making powerful predictions, really easy. So, what does that mean for social good? I think it means everything. I think it could turn our world upside down. So, it means using AI to predict the effects of a policy on marginalized and underserved communities. It means detecting fake news to make sure that everyone is getting the facts. It means what I've done in this study, using machine learning to replace this system of suicide risk assessment and treatment that's been entrenched for more than 70 years that doesn't work for us, and replacing it with a data-driven system. There's going to be so many considerations when implementing any of these tools, right? We need to look at upstream and downstream contributors. Like, humans are flawed, so we need to make sure our machines aren't flawed too. So we need to have those considerations, but we shouldn't knock on machine learning as a tool because it can do so much good for us.
Thank you so much. You can't help but feel hopeful after learning about all these amazing students' research. Next up, meet our radical mathematical teens in just a few minutes. Thank you.